All right, moving on to basically sketching this function. So this is a long question, but the good news is there's 5 questions on the test instead of 6, so you can dedicate more of your time to this and you'll be okay. So the goal of this question is to basically fill in everything here, and then we're gonna use all of this info to graph the function, which sounds crazy, but bear with me, okay? I'm going to show you a really nice way to organize everything so that it's less intimidating, okay? So, yeah, we need to do all of this. And it all stems from the first derivative, okay? So, to get all of this, we need f prime. We also need f prime for this. This one we need f double prime. And this one we need f double prime. So really, we just need to take a couple derivatives, okay? Which your function will be nice. It'll be a polynomial. So the derivative portion should be okay. Just don't be weird and goofy and multiplying correctly, and you should be fine, okay? So, step 1. Find f prime of x, okay? So, we get what? 3x squared minus what? 6x? Okay, beautiful. Step 2. Set f prime of x equal to 0 because we're going to find our critical values. Why? Because that's where maxes and mins occur, and that's what we need to do that. Okay, this will also help us figure out intervals of increase, decrease. So basically, when in doubt, take a derivative, set it equal to 0. Okay? So, let's do that. Let's do 3x squared minus 6x equals 0. Let's make our life a little bit easier here and note that these both have a 3x. So why don't we take a 3x out of both of these? What's left? X minus 2. Okay, so 2 possibilities for this function being 0 is when, well, x is 0, because 3 times 0 will make that whole thing 0. We'll make this 0, 2. Really, that's what we were doing here is we were doing 3x equals 0, and we were doing x minus 2 equals 0. So that's where I got x equals 0 and x equals 2 from. Okay? Alright, so these guys are our critical values. Critical point, critical value, doesn't matter. Alright, great. We still haven't found anything on the list, but we're getting there. Alright, now we are going to, so these 3 things, we're going to do them all at the same time. Okay? So once you have your critical values, we're going to draw a nice little chart. Here, let me do this. Step 3. Chart. Okay. So we're going to draw a chart, and we're going to look at what's happening around our critical values, 0 and 2. Okay? Because these are the 2 places where the derivative is equal to 0. That means everywhere else the derivative is either positive or negative. Okay, and remember, the derivative, when it's positive, that means f is increasing. When the derivative is negative, f is decreasing. That's why we need this, okay? So we're going to see what's happening on the derivative to see what's happening on f, okay? So I want to figure out what's happening between 0 and 2. So let's look at, I don't know, 1. I also want to see what's happening after 2. So maybe I look at 3. And I want to see what's happening after 0. So maybe let's look at negative 1. Because remember, at 0 and 2, this is when the original function f changes from increase to decrease by definition of critical value. Okay, so if I plug negative 1 into the derivative, okay, I'll have 3 times negative 1, which is negative, and then I'll have negative 1 minus 2, which is also going to be negative. So negative times negative gives me a positive value. So the derivative is positive for values that are less than 0. Great. Let's plug in 1 into the derivative. 3 times 1, that's positive. 1 minus 2, that's negative. Positive times a negative gives me a negative number. So the derivative is negative between 0 and 2. Let me plug in 3. I'm going to have 3 times 3, which is positive, times 3 minus 2, which is also positive. Positive times a positive gives me a positive number. Okay? So that means f is increasing up to 0, and then it starts to decrease until 2, and then it starts to increase again. All right, so now we found intervals of increase, decrease, and we found some maxes and mins. So because it increases up to 0, and then it decreases afterwards, that's a maximum value. And then 2 is a minimum because it decreases and then it increases. Okay, so we found a lot of info, but we haven't done the absolute min and the absolute max. To find the absolute, we're going to do an x versus f of x chart, where we check our critical values, 0 and 2, and we check our endpoints. Remember that? And then we plug this into the original. I don't have a calculator handy on me, so you guys can figure these out on your own. You get these y values. The largest one is your absolute max. The smallest one is your absolute min. Cool? Where here we can call these like local mins and local maxes, but remember, if something's an absolute max, it's also a local max. Okay? All right, so from here we can figure out our intervals of increase, decrease. So it's increasing. So technically we only care about -1 to 3. So like technically this function is increasing from -infinity to 0, and then also from 2 to infinity. But because we only care about the interval from -1 to 3, let's just write our answer according to that, just so that we don't upset the grader, which might be me, I don't know. So really -1 to 0, and then 2 to 3. We can include 3 in -1 because technically it is increasing at -1. Okay, and then decreasing is going to be everywhere else, which is just between 0 and 2. We don't include 0 and 2 because that's where it changes from increase to decrease. So it's not doing either at 0 or 2. Okay? Great, that was half of it. So we got increase, we got decrease, we got local max, we got local min, and then you can tell me what the absolute min and max are from plugging this into your calculator. I say that, but you can't use your calculator on the test, so that's your problem. Okay, cool. What's left? Inflection points and concave up and concave down. Well, we're going to do the same exact thing that we just did, but with the second derivative. Okay? So let me erase this. Okay, close enough. Okay, so what was our first derivative? Our first derivative was 3x squared minus 6x. That means our second derivative, here, let's call this step 4. Find second derivative. Well, that's going to be 6x minus 6. step 5, if we're keeping score, is set the second derivative equal to 0, because this is going to find our inflection points. Okay, 6x minus 6 is equal to 0. Let's take a 6 out just because we can. So we only have one inflection point, which is x equals 1. Okay. Step 6. Another chart. I know. Okay. So, again, at this x value, this is the only place where the second derivative is 0. That means everywhere else the derivative is positive or negative, which means we're either concave up or concave down. So, let's see what's happening at -1, and let's see what's happening at 2. Does it matter which number I pick? No. Just make sure one is above and one is below. Pick what's going to be easier for you to plug into the derivative. You know what's actually easier than 1? 0. Okay, let's plug 0 into the derivative. 0, or 6 times 0 minus 1, that's negative. Let's plug 2 into the second derivative. That's positive. Okay. If f double prime is positive, f is concave up. If the second derivative is negative, f is concave down. So f is concave down here and concave up here. So up, we are 1 to infinity, and down, we are negative infinity to 1. Again, we only care about -1 to 3. So we might as well write that. You wouldn't be wrong by writing the infinities, but again, you might as well just only report about what's happening on -1 to 3. Cool? Great. Let's see. Concave up, concave down, inflection points. You guys take care of this on your own. What's left? Drawing it. Okay. Couple things. I know my critical points are x equals 0 and x equals 2, and I know my inflection points are at x equals 1. Why don't we plot those? Why don't we plot f of 1, f of 0, and f of 2 first, so we have somewhere to go off of? Okay? Remember, we're trying to do what again? X cubed minus 3x squared. Alright, if I plug 0 into there, I'm 0. If I plug 1 into there, I'm what? -2? Does that make sense? If I plug 2 into there, oh god. Okay, we're 2 cubed, which is 8, minus, oh god, 2 squared is 4, times 3 is 12, oh god, -4, hopefully. So why don't we plot those just to have somewhere place to start? Okay. Why don't we also plot our endpoints? -1 and 3. All right, -1 is going to be, I think, -4, because we get, that's -1 minus 3, yep. Okay. If I plug 3 into there, oh god, 3 cubed is 27 minus 3 times 3 squared, that's 3 cubed, so that's 0, right? Sure. Okay. So we're just going to plot these, and now we're going to play a game of connect the dots. Okay? So you want to plot your critical points, you want to plot your inflection point, and you want to plot your endpoints using the original. That's what we're trying to plot. The only reason why we needed the derivatives is to figure out all this madness. Okay? So before we do that, let's draw one more chart. Let's draw one big cohesive chart, and then we'll be good. Okay? So, step 7. Haha, 6, 7. Big chart. And now we're going to look at what's happening everywhere. So we're going to look at our critical points and our inflection points. So 0, 1, and 2. We're going to see what's happening on F prime, F, and that'll give me the shape of F. Okay. So, we said between 0 and 2, what? Were we decreasing? Yeah, we were decreasing. And we were increasing. Okay. Let's see. At 1, I believe we were concave, what? We were down first, right? Concave. Oh, I did this backwards. There we go. Yeah. We were concave down, and then we were concave up. Okay, so what we're going to do in this third column is we're going to draw what that looks like. We're going to draw what increasing concave down looks like, and that looks like this. And then we're going to draw what concave down decreasing looks like. And then we're going to draw concave up decreasing. And then increasing concave up. Okay, so what we're going to do is we're going to basically connect the dots according to this, okay? So between -1 and 0, I'm going to look here. So that's increasing concave up. Between 0 and 1, it looks like I'm decreasing concave up. Decreasing concave down. Jesus Christ. Between 1 and 2, I'm concave up decreasing. That's because I plotted this wrong. So sorry about that. That's why we plot things, to make sure it makes sense. Between 2 and 3, we're concave up increasing. So you see how those shapes kind of just fall into place here? Hopefully. So yeah, when in doubt, take a derivative, take a second derivative. Take your critical points, take your inflection points, draw a chart, see what's happening, put it all together. And you'll be good, okay? You'll be good, I promise you.